All right, guys, so you're watching this video, and what I realized this afternoon is that my software for my Elmo is not working properly to have you guys on Teams watching me go through the review problems. So when I finished with iReady testing at 1:50, I started making this video, and you are logging in at Teams, and I'm talking to you about it right now, and it's 2 o'clock. So as you are imagining, I had about 10 minutes to make this video, so I'm going to do the best that I can, and we are going to kind of buzz through the review and talk about these things, and then hopefully if you have any questions, you'll reach out to me. But let's take a look at question number 1. The question wants to know, so out of these figures, a parallelogram, a rectangle, a rhombus, and a trapezoid, which one cannot describe a square? Meaning a square could be still classified as all but which one? So that seems like a really tricky question, but for me, I look at these and I think, okay, but what do I know about these? Well, a parallelogram has 2 pairs of parallel sides. So does a rectangle, and so does a rhombus. And a square also has 2 pairs of parallel sides, but there's something different about the trapezoid. A trapezoid only has 1 pair of parallel sides. So when we say which one cannot describe a square, that is a trapezoid. Because it has only 1 pair of parallel sides. Question number 2. How many acute angles are there in an equilateral triangle? So this is something you talked about with Mrs. Connor, and I know that the beginning of this word equilateral kind of reminds me of equal. So I know all 3 sides are going to be the equal meaning equal length. So when I draw that equilateral triangle, again, all 3 sides are the same length. Now I can answer that question. Well, I look at angle number 1. That angle is acute. When I look at the second angle, it is also acute. And the third angle is also acute. Well, that makes sense. If all 3 sides are the same length, then the 3 angles are also going to be the same. So an equilateral triangle has 3 acute angles. Let's continue on. Question number 3. I'm going to zoom in a little bit so you guys can see this a little bit better. Gavin drew different colored lines. Draw a line that is parallel to line SR. So I am going to grab a highlighter. You can see line SR is running right along here. Parallel means it's going to run right next to it, and they're never going to meet or cross. So I could start with something like going through line U. It's not perfect because I'm not an artist and I don't have a ruler, but that is a line that is running parallel to SR. Let's look at question number 4. Marcy described the light from the sun as a line that starts at the sun and continues on forever. Which geometric term best describes Marcy's description of the sun's light? So I actually did this with a couple of you guys where I talked about like when you're younger and even me, and I draw the sun, right? And we know that it's going on like forever and ever because it's just shining brightly. So I drew like the little arrows at the end to remind us of that. So the question is asking what geometric term this is describing. And if you think of the geometric term, well, that's kind of like the end point, the circle, and then the line that's traveling on forever. And if you're thinking a ray, like a ray of sunshine, you are correct. This is a ray. All right, moving right along. Question number 5. Great. 4 of Mrs. Cromwell's students decorated a bulletin board with the shape shown below. Order the students' shapes in order from the fewest lines of symmetry to the most lines of symmetry. So we have these names: Ralph, Liza, Patricia, and Dan. Well, I look at this right away and I can see that Liza, I don't think Liza really has any lines of symmetry. I was going to say right through the middle here, but this circle means that she has none. So Liza is going to be the fewest. So I'm going to put her name down first because she actually has 0 lines of symmetry. After Liza, now I need to look, I almost want to cross her off to get her out of my brain. Now I'm going to look at the remaining students: Ralph, Patricia, Dan. Well, with Dan, I could cut this figure right down the middle. This side would meet this side perfectly, or I could cut right across the center. And if I fold the top down, it would meet the bottom perfectly, so Dan will be second. Now I've narrowed it down to Patricia and Ralph. Well, with Patricia, I could cut the star right down the middle, and then if I fold this over, imagine this point of the star would meet with this one would go here, and then this one would come right over here. So that's 1. Now you could do that through each of the points in the star, almost like you're turning it. So I have 1, 2, 3, and 4. So now I have Patricia. That leaves Ralph. So I could cut a line through each one of these points. So right down the middle, 1. And then let's just go like clockwise. So here's 2, 3, 4. But now there's something different. What about in between? 5, 6, 7, and 8. So Ralph has the highest number.